So you've written a Node.js script, and hey, it runs. That's awesome. But how do you get from that simple script to a full-blown application that can handle millions of users without breaking a sweat? Well, in this explainer, we're going to cover that entire journey, from it works on my machine to it's genuinely production ready.
So, what really is the secret sauce here? What's the magic that turns a basic app into a powerhouse? Here's a hint. It's not just one single trick. It's a whole series of deliberate, smart engineering choices that we're about to break down, one by one.
And that's the journey we're going on today. We're going to start with the fundamental physics of the Node.js engine itself, and then build our way all the way up to the kind of architecture that powers massive global applications. So let's start at the very core.
First things first, if you want to build amazing things with any tool, you have to understand how that tool thinks. And for Node.js, that means getting really comfortable with its core engine.
You know, the absolute heart of Node is the event loop. The best way to think about it is like a brilliant but very single-minded chef in a kitchen. This chef never does the slow work, like chopping vegetables or waiting for water to boil. Nope. Instead, they hand that work off to their kitchen assistants and immediately start on the next order. Then, when the veggies are finally chopped, an assistant just brings them back. That is non-blocking I/O, and it's the magic that lets a single thread handle thousands of connections at once.
Now, here's where it gets really interesting, because there's a hidden hierarchy here. It's not just a simple first-in, first-out line. After your main code runs, Node will process all of the pending microtasks. Think promises and async await before it even looks at a single macro task, like a set timeout. This priority system is exactly why async await feels so instant and responsive.
So, the most important point is this. If you give that chef a task they can't delegate, like asking them to solve a complex Sudoku puzzle right then and there, the entire kitchen grinds to a halt. That's what we call blocking the event loop. Any heavy, synchronous CPU work will literally freeze your server solid, making it totally unresponsive. The name of the game is to always keep that main thread free. Okay, so now that we have a handle on the engine's physics, let's start building on top of it. It's time to start using some of the more advanced features to construct a truly robust and reliable application.
You know, modern JavaScript gives us this incredible toolkit to work with. For instance, a proxy lets you intercept and control operations on an object, which is amazing for creating powerful validation systems. And weak maps, they let you attach private data to objects without ever having to worry about causing memory leaks down the line. These aren't just fancy syntax, they're genuinely powerful tools for writing safer, more elegant code.
Now let's say you need to process a huge file, maybe a couple of gigabytes in size. If you tried to load all of that into memory at once, your app would just crash. This is where one of Node's true superpowers comes into play: streams. This modern pipeline function you see here just elegantly handles it. It reads, compresses, and writes the file piece by piece or chunk by chunk using an absolutely tiny amount of memory.
And here's how that beautiful code actually works under the hood. Data flows in these small chunks from the source file, it gets compressed on the fly, and then it flows right out to the destination file. The best part is, the pipeline utility automatically handles something called back pressure, which basically means if the writer gets a little slow, it tells the reader to pause for a second. It's a fantastic, self-regulating system for handling massive amounts of data.
Okay, so we've built a really solid application running in a single process. But what happens when you get a huge spike in traffic, or you want to use all 8 cores on your fancy new machine? Well, now it's time to start thinking about architecture.
Right, so to break out of that single thread, you've got options. If you have a really CPU-heavy task, like resizing a user's profile picture, a worker thread is the perfect tool for the job. Need to run a completely separate command line tool? You'd use a child process for that. And if you're building a massive, complex system where different teams own different features, you'd probably design it using microservices. And as you get to a larger scale, event-driven design becomes absolutely essential. Instead of services calling each other directly, they just produce events, like order placed, and fire them off into a message queue. Then other services can listen for those events and react. This decoupling is incredibly powerful. It means your notification service can go down for an hour and it won't stop new orders from being processed. This is how you build truly resilient systems. We're almost there. The final part of our journey is about professionalism. It's about the tools and the practices that make an application secure, reliable, and actually maintainable out there in the real world. Look,
Security is completely non-negotiable. This means you have to sanitize all user input to prevent things like SQL injection. You should use libraries like Helmet to set secure HTTP headers. You need to rate limit your API endpoints to stop abuse. And most importantly, you must never, ever, ever commit secrets like API keys directly into your code repository.
When things go wrong in production, and trust me, they will, how do you figure out why? You need observability. It's built on 3 pillars. Logs tell you what specific event happened. Metrics give you the big picture, aggregate view, like overall CPU usage. And traces. Traces follow a single request as it jumps across all your different services, showing you exactly where the bottleneck is. You absolutely need all 3.
And this right here, this is what a professional, production-ready artifact looks like. This is a multi-stage Docker file. It builds the application in one temporary stage, and then it copies only the compiled code and the necessary production dependencies into a final, clean, lightweight image. This creates a small, secure, and perfectly reproducible unit you can deploy anywhere.
So let's bring it all home. This whole journey from a simple script to a production system really boils down to a few core principles. First, write clean, non-blocking async code, and please, handle your errors. Second, for large data, think streams, not buffers. Third, get that heavy CPU work off the main thread. Fourth, build in observability from day one, not as an afterthought. And finally, automate your testing and deployment. This is the blueprint.
We've covered the entire map, from the deepest parts of the core engine all the way up to global systems. The path is laid out right in front of you. The only question left is, where are you going to begin your next deep dive? Thanks for joining me.